Hello my dear students, welcome back to the discussion on solved problems in fluid mechanics. The topic for today's discussion is buoyancy. What is buoyant force? Buoyant force is an upward force exerted by any fluid upon an object placed in it. In other words, buoyancy or upthrust is the upward force exerted by a fluid that opposes the weight of partially or fully immersed object. When a body floats in a liquid, the bottom portion of the body that is immersed in the liquid, whereas top portion of the body that is in contact with the air. Weight of the floating body that is acting down through the center of gravity, whereas buoyant force that is the upward force exerted by the fluid or exerted by the liquid that is acting in the upward direction which opposes the weight of the body. So if this body is in equilibrium condition, both forces are in line. So buoyant force is indicated by Fb and it is acting through the point that is called center of buoyancy. Center of buoyancy is coinciding with the centroid of this displaced volume. Now, based on the principle of flotation, weight of the floating body that is equal to weight of the fluid displaced by the body. So this floating body is concerned, bottom portion of this floating body is immersed underwater, whereas top portion that is in contact with the air. So V air indicate the volume fraction of this floating body which is in contact with the air, and V water which indicates the volume fraction of this floating body which is in contact with water. Now based on the principle of flotation, weight of the floating body equal to weight of the fluid displaced by the body. So in this case it is weight of air displaced plus weight of water displaced. So weight of air displaced calculated by multiplying contact volume of air into density of air, and so weight of water displaced is calculated by multiplying volume of the body which is in contact with water by density of water. Since weight of air displaced is negligible in magnitude, we can consider weight of floating body equal to weight of water displaced. So based on this principle, now we can solve a problem. So figure shows a cylindrical vessel of 150 mm in inner diameter is filled with a liquid of specific gravity 0.8 up to a depth of 100 mm. A solid cylinder of 100 mm height and 100 mm diameter weighing 4 Newton is immersed in the liquid contained in the vessel. So excess be the initial level of liquid. So when the cylinder immersed in the liquid, the level changes and YY indicate the rising level of liquid. So we have to determine the level of liquid at which the solid cylinder will float. Let X be the depth of bottom surface of the cylinder with respect to the original level, and Y indicate the rise in water level. The theoretical details of buoyancy concepts is discussed in this video. So if you want more details, one can refer this. So when we are dropping the solid cylinder, the volume of liquid depressed that is equal to volume of the liquid risen. So volume of the liquid depressed that is equal to cross-sectional area of the cylinder multiplied with X. X is the depth of bottom surface of the cylinder with respect to the original level. So volume of liquid depressed equal to volume of liquid risen. Diameter of the cylindrical vessel is 150 mm and diameter of solid cylinder is 100 mm. So this volume of liquid risen can be calculated as pi by 4 into 0.15 square minus 0.1 square multiplied with the rise in liquid level. So if you are equating and simplifying, you can establish a relationship between X and Y. Now we can apply the principle of flotation, which says that weight of the floating body that is equal to weight of the liquid displaced by the body. Weight of this floating body or weight of the solid cylinder is given as 4 Newton. So 4 equal to weight of the liquid displaced, that is the volume of the submerged portion multiplied with the specific weight of the liquid. So specific gravity of the liquid is given as 0.8. So how will you get the specific weight of liquid? So we have to multiply the specific gravity by specific weight of water. So rho g multiplied with 0.8, that will give you the specific weight of this liquid into cross-sectional area multiplied with the X plus Y, that is the total depth of immersion of this cylinder. Again you will get an expression for x and y, that is x plus y equal to 0.0649. So we have two unknowns x and y and two equations. So we can solve this and we can find out the value of x and y. So x equal to 0.0361 meter and y equal to 0.0288 meter. So in this problem, we have to determine the level of liquid at which the solid cylinder will float. It is given that initial depth of liquid, that is equal to 100 mm. So 100 plus y will give you the new level of liquid. So that is equal to 100 mm plus 28.8 mm, that is equal to 128.8 mm from the bottom of the vessel. So the new level of liquid is at a distance of 128.8 mm from the bottom of this vessel. So this technique you can use to check the overflow level of the liquid when we are dropping a solid into it. Next problem we are going to discuss is regarding the stability of the floating body. So stability of the floating body mainly depends upon metacenter. In this problem, a solid cylinder of diameter 3 meter and a height of 2 meter is floating in water with its axis vertical. Specific gravity of cylinder is given as 0.6. State whether the body is stable or not. So for a floating body is concerned, stability depends upon the position of M with respect to G. So if M is above G, then we can say that the floating body is stable. Or metacenter height Gm, that is positive. The determination of metacenter and metacenter height for a floating body is discussed in this video. For more theoretical details, you can refer this. G is the center of gravity of this floating body, that is the point through which this weight of the cylinder acts in the downward direction. Buoyant force which is acting through the center of buoyancy. H is the depth of immersion and L is equal to 2 meter, that is height of this cylinder. Now based on the principle of flotation, weight of the floating body, that is equal to weight of the liquid displaced. So how will you find out weight of the floating body? That is equal to volume of the cylinder multiplied with specific weight of the material of the cylinder. So specific gravity of the cylinder is given as 0.6 multiplied with specific weight of water will give you specific weight of this material of this cylinder. So volume of the cylinder equal to pi by 4 d square L. Pi by 4 d square, that is a cross section area, multiplied with the L will give you the volume of the cylinder multiplied with the specific weight of cylinder. That will give you the weight of the cylinder, which is equal to weight of water displaced. So let us consider H is the depth of immersion. So pi by 4 d square into H is the submerged volume of this cylinder multiplied with the specific weight of water, which give you weight of water displaced. If you are substituting and equating, then H equal to 1.2 meter. So center of buoyancy is defined as centroid of this submerged volume, so which is equal to H by 2, whereas center of gravity, that is the point through which weight of the body that is acting in the downward direction, so that is equal to L by 2. So we can calculate the position of center of buoyancy with respect to the bottom of the cylinder as OB equal to H by 2, and the position of the center of gravity with respect to the bottom of cylinder OG, that is equal to L by 2. The equation for the metacentric height, that is Gm, that is equal to Bm minus Bg. So Bg can be calculated as Bg equal to OG minus OB, that is equal to 1 minus 0.6, that is equal to 0.4 meter. Next step is to calculate Bm. So how will you calculate Bm? So calculation of Bm is discussed in this video. So Bm equal to I by V, where I is the moment of inertia of the top view at water surface about Yy, or it is moment of inertia of this cylinder, that is equal to pi into d raised to 4 by 64 equal to 3.974 meter raised to 4, and V is the submerged volume of this floating body. The depth of immersion we calculated as 1.2 meter. So volume of cylinder submerged in water, that is equal to pi by 4 into d square into h, that is equal to 8.48 meter cube. So we have learned previously that Bm equal to I by V. So we can calculate Bm, that is equal to 0.4696 meter. Metacentric height is Gm, that is equal to Bm minus Bg. So if you are substituting, then metacentric height obtained as 0.0696 meter. So if you are substituting, metacentric height is calculated as 0.0696 meter, which is positive. So that means our assumption, that is position of M is above G, that is correct. Or we can say that this floating body, that is in stable equilibrium. For the time being, it is enough. Thank you.